Carrying capacity is the size of a population that can be supported indefinitely by the resources of a given ecosystem. No additional individuals can be supported, at least for long. So this video I have here by White Bone Creations is just this guy that does YouTube videos about some taxidermy. In any case, he talks about conservation. He talks about sustainability. And so I want you to watch that video now. When a population is maintained at its carrying capacity, the size of the population is maintained in balance. The number of individuals added is in balance with the number that leave or die. When one of the necessary resources is being used at a rate that exceeds the carrying capacity of the ecosystem, the population will eventually be reduced in size until it is once again in balance with the available resources of its ecosystem. The impact of limiting factors on exponential growth has been seen with the populations of northern fur seals. In the 1800s, the fur trade led to a drastic reduction in the northern fur seal population. Its decline prompted the first international treaty ever designed to conserve wildlife, which was signed in 1911. The graph below shows the growth and eventual leveling out of the population of northern fur seals following the treaty. So remember, we have a graph showing breeding male fur seals in the thousands, and then we have the years, right? So 1915, 1925, and so forth, okay? And so we had around 1,000 at the beginning when the treaty was signed. And then we see a slow J curve, right? And that it reaches its carrying capacity and levels out. Sometimes wildlife biologists and park or resource managers need to know the carrying capacity of populations they're studying or managing. Measuring the numbers of individuals in a population can be done either directly by counting or indirectly by estimating. So the example I give here, populations of white-tailed deer are estimated through a method called pellet group counting. This involves counting piles of pellets, okay, or feces, left during the winter months. Interactions among species. I'll say that again. Resource needs and abiotic factors are not the only influences on population growth and size. All organisms interact with other species in multiple ways, and these interactions can have positive and negative effects on a population. A species' ecological niche, okay, is when a species spends most of its time doing two things, okay, surviving and reproducing. They do not have jobs in the same way that we have jobs or humans have jobs. As they go about doing their regular daily activities, they consume food and interact with other species. They have jobs in the sense of providing benefits to their own ecosystem. The resources that are used by an organism and the abiotic limiting factors that restrict how it can survive, as well as the biotic relationships that it has with other species, all make up an organism's ecological niche or niche. The example I give here is the video that I just had you watch about the little brown bat. A brown bat's ecological niche includes both biotic and abiotic factors. The biotic factors are all the insects they eat, their competitors, and their predators. Okay. Abiotic factors are places that they use to roost and hibernate. Okay. The time of night that they hunt for food, the airspace that they fly in when they hunt, and the temperature range that they can tolerate. Different species provide many different services to their ecosystems by occupying their ecological niche. These services may include the regulation of population size of other organisms, as well as specific services related to matter cycling or energy flow. Remember, decomposers, different animals, we're transferring energy, we're transferring nutrients when they're eaten. Okay, brown bats, their niche helps to regulate insect populations. I've got a bat house at my home. Okay, I got for Father's Day one year that helps to regulate the insects in the area. They also support cave-dwelling organisms that depend on the nutrients found in their droppings. For that matter, out of my bat house, any of the bat droppings that hit the ground obviously go into the ground, and decomposers use as food as well. No two species can occupy the exact same ecological niche or provide the same services to that ecosystem because no two species live in the exact same way. They might be similar, but not the same. Well, here's the definition of an invasive species. It's a species that could take over an ecosystem of native species. Okay, so the example I give you here is of zebra mussels. If you go out boating, then you will know that you'll see some of these posters around. You can see in the bottom right-hand corner here how tiny they are. You may have seen them on your propellers of your boat or the hull of your boat. There are instructions that we're given when launching and before leaving to try to mitigate the issue of transferring them anywhere else, because they are not native to where they are. They've taken over quite a few lakes in North America, actually, and it's up to us to prevent their spread. So this is just a quick look at what the zebra mussel looks like close up. Okay, it's 1 to 3 centimeters, triangular or D-shaped. Mostly have light and dark brown bands on the shell. Okay, adult shells are very strong and tough. Okay, and they usually come in clusters. That's the thing, that they take over, right? There's also wild pigs loose in Manitoba. These are wild boars. It is open season on them. There's no season on them in Manitoba. They were previously from Europe and have taken over much of North America. And in Texas, actually, there's hunting parties that you can go out and hunt them in large quantities to help, because they will destroy crops. I've heard of farmers that have a $250,000 crop ruined in one night from these pigs. Okay, an alien species. This is different than an invasive species, and it's important to know the difference. Okay, this is a species that is introduced either intentionally or accidentally to a new location. They can be either a benefit or a detriment to their new location. So I've got an example here These guys first showed up in Manitoba in the year 1900. And so I want you to kind of think of a fairly prolific animal, a fairly common animal that is fairly large in Manitoba. And check this out. So the deer, the white-tailed deer, came into Manitoba around the early 1900s. Okay, it was not native to this area before that. Most species must adapt to the environment they live in. Find a new environment or risk dying. So the example I give here is of carnivorous plants. Okay, these plants often live in bogs where there is ample water, okay, and sunlight, but often the nutrients the plants need are not present because the soil is too acidic. Okay, carnivorous plants have adapted to be able to catch insects and break them down to get the nutrients that they need in order to survive. The fact that most organisms are limited to particular niches is partly why different species are only found in specific types of ecosystems in specific parts of the world. Humans have a brain that has allowed us to move out of the narrow niches that was inhabited by our ancient ancestors. Okay, this is our main tool right here. By building complex tools, okay, controlling forms of electrical power or energy, and expanding our use of resources, okay, humans have been able to live successfully in many different ecosystems, including deserts. Okay, this is an overhead shot of Dubai in the United Arab Emirates. Right, this is in the desert, a giant city, or the Arctic. An Arctic ecosystem. I believe this is Anchorage, Alaska, but I could easily have been Churchill, Manitoba, right? We've constructed our own niches, essentially. For humans to continue to occupy such a broad niche, we must use the ecosystems we inhabit and the resources they contain in a sustainable way. Right? This is why there's such an emphasis on reduce, reuse, recycle, on using sustainable forms of energy and sustainable forms of farming and food. Sustainable use of resources is use that does not cause long-term depletion of the resources or affect the diversity of the ecosystem from which the resource is obtained. Sustainable use of a resource allows the resources to meet the needs of present and future generations. The populations of most species are regulated by the carrying capacity of the ecosystem that the species occupies. Remember that that's the amount of resources that are contained in a specific area that are required for those populations to exist. The intellectual abilities of humans have allowed us to create our own niches, as well as increase the carrying capacity of the planet for our population. By improving public health, education, and agriculture and medicine, and technology, we have increased the carrying capacity for humans. Right? So by improving public health, right, agriculture, different technologies, our ability, instead of building a home, one home that fits one family, we can build entire cities, right? I believe this is New York here, right, where we build upwards so we can fit more people in a smaller amount of space because we can build up. Our foods that are engineered, we can argue that they're not healthy for us or that they are healthy for us, depending on where you stand on that. But the fact of the matter is, it's allowed our population to grow and allowed us to become what we are today. The Earth's population of humans has been increasing exponentially ever since the Industrial Revolution. So the question is, will we hit a carrying capacity? And if so, will we level out? Right? Right now we're at about 7.5 billion. Remember that exponential growth cannot be maintained in nature. Altering an ecosystem so that more energy and resources can be consumed is only one way that we increase the carrying capacity of ecosystems. The second way is to increase its carrying capacity involves altering our behaviors rather than the ecosystem itself. An ecological footprint is a measure of the impact of human individuals or populations on the environment. A person's ecological footprint is calculated using their energy consumption, land use, and waste production. The average person in developed countries, including Canada, has one of the largest ecological footprints in the world. Ecological footprints this large in a world that has finite limit or limited resources and is dependent on non-renewable fossil fuels are likely to be unsustainable. It's important to embrace the principles of sustainability. Use of the Earth's land and water at the levels that can continue forever. I'm going to read that again. It's important to embrace the principles of sustainability. Use of Earth's land and water at levels that can be continued forever. Ways that we can reduce our ecological footprint include consuming fewer resources and using existing resources more efficiently through technological innovations, energy efficiency, and recycling.